In the last one, we're looking at how the motion would be affected if the springs are in parallel compared to if they're in series. And there's 3 springs. In the A version, there are only 2 springs. And I think the one we did in class was just had 2 springs. This one has 3 springs. But if I have 3 springs that are in parallel, so there's one, there's another, and there's another, and they are going to be attached to some block, some mass, and the mass is 2 kilograms. Now, and the question is asking, what's the angular frequency? The angular frequency, understand the difference between the 3. Angular frequency is omega. So this thing right here, that is omega, which means it's going to be measured in radians per second. That's not regular frequency. We've got 3 things that are related, but they're not the same thing. T is the period. That's going to be measured in seconds. The italics F, that's the frequency. And that's going to be measured in hertz, which is second to the -1, because what it is, it's the inverse of the period. The frequency represents how many cycles happen every, a certain amount of time, per time. And then you've got omega, which is sort of like how fast it's actually moving angularly. When we think of, how fast am I getting from the 0 degree to the 90 degree point on the graph, if I were to graph the motion, simple harmonic motion, how fast is that happening? So that's angular frequency, and the units for that are radians per second. So that's what they're asking for in this problem. What is the angular frequency? So we have a very simple formula for that. The angular frequency is just the square root of k over m. That's our formula. So all you need to do is get the k and the m. Now, if it was the period, let's say, because I know in another version, in the A version, I didn't ask for the angular frequency, I asked for the period. Well, the period formula is T equals 2 pi square root of m over k.
So wait.
So
why do you even need to do anything with the period?
I don't. I'm just saying that maybe on the C version I ask you for the period instead of the frequency. It's still the same 2 variables you have to figure out. So if it was the period, you'd use that formula. If it was the frequency is 1 over the period. So if I wanted to know what the frequency was in terms of m and k, it would actually be 1 over 2 pi, because this thing would be flipped over, and that's going to be flipped over. If frequency is the inverse of period, then that's 1 over 2 pi, and that part's going to be square root of k over m. So here are the 3 options that I could give you on the test, that if I ask for angular frequency, you're going to use that formula. If I ask for the period, you're going to use that formula. And if I ask for the frequency, you're going to use that one. Tanner, you paying attention? Okay, I mean, we're going to have a retake tomorrow. I'd make sure I'm paying attention to this. So now, the good thing is when we're in parallel, because these 3 are in parallel, the equivalent k in parallel is just add them up. So I'm just going to add up, there's 3 of them, and they're all 3 newtons per meter. So the equivalent is 9 newtons per meter. So I'll plug in 9 down there, and I'll plug in 2 there. I'm sorry, we're solving for angular frequency. So I'll plug in 9 there and 2 there, and that will give me the angular frequency in parallel. Yes?
I'm pretty sure that first equation you put on there, omega equals it's not on the formula fact sheet.
Every formula is, every single version is not on the formula fact sheet. I've talked about that. We've done this problem out. What?
Is that a different version of?
We have a formula. Omega is 2 pi over t.
Yep.
And that is this, if I plug in 2 pi.
Oh yeah, I see it. It's just a little weird because you take the formula for t with m and k in it, and you just plug it in and you get the answer.
I mean, this, the 2 pi's will cancel out. I have 1 over the square root of m over k, which is the square root of k over m. So so I'm not going to give you, just like when I give you the straight line motion equations, I don't like to give you VF equals VO plus AT, and also VO equals VF minus AT, and also A equals VF minus VO over T, or whatever I said. You know, I don't give you like every single rearrangement of an equation. I give you enough equations so that you can use them. So, you know, we do this enough that might be something that if you've done a few of these problems prior to the test, you sort of have that memorized. It's almost, if you know that one, you know that omega is like the opposite of that. Like if that's m over k, then omega is square root of k over m. So I would just plug in those numbers. That would give me that. And now if they were in series, then in series, it's like when we were solving for the equivalent resistance in parallel with electric circuits. So the equivalent in series, so if those circuits, if those 3 springs were in series, meaning I have this, oh, there we go. I didn't think it was going to come up. And so that's 2 kilograms. So if that is how the springs are, then the equivalent spring that I can replace those, I want to replace those 3 with 1 value. I want 1 value for my k. So the value is going to be, I'm going to use the formula 1 over k equivalents is going to be 1 over k1 plus 1 over k2 plus 1 over k3. And each one of these is 3. 3 newtons per meter, 3 newtons per meter, 3 newtons per meter. And for some of you, it's just 1 because 3 over 3 is 1. So even if I flip it over, I get 1. Okay, now if there were only 2 of them and I flip it over, so that would be 2/3, which I would flip over and it would be 3 over 2. But with 3 of them, 3 over 3 is 1. So even if you forget to flip it over, you'd probably still get the correct value. So K equivalents is going to be 3 newtons per meter divided by 3, which is 1 newton per meter. So again, I'm just going to go to this formula over here and plug in those 2 numbers. And then you'll have the answers. And the answers, the 2 answers, let's see, I'm already at over almost 8 minutes. So if I solve in parallel, so the omega in parallel is going to be the square root of 9 newtons per meter divided by 2 kilograms. And that came out to be 2.12. If I do the angular frequency for the series, that's going to be 1 newton per meter divided by 2 kilograms. So this should be 1/3 of what the other one was. And the reason why I know it's 1/3 is because that's 9 times bigger than that. So that, and it's under a square root. So if I take the 9 outside, it's really, this number is 3 times bigger than that one. And so the answer for this one comes out to be 0.71 radians per second. So I put some extra stuff there that other than just the solution to the problem, but that's because, you know, on the B version, or the C, this was the B version, so on the C version, maybe instead of me asking you for what the angular frequency is, maybe I ask you for the period. Or maybe I ask you for the frequency, not the angular frequency, and so you've got other forms of this equation. Any questions? All right. So that takes care of the 2 that I had